Now I'm going to work on problem 17, and this is still test 2 review, and it's this problem here. I'm doing prime factorization. So let's look at that. We're going to find the prime factorization of 8800. I'm going to use the cake method or the tree method and another approach. So if you've already watched some of these prime factorization videos, I'm going to start with the other approach, and you can see how that works first. So with this way, what I do is I take the number and I just look at it and say, well, what can I say? Where can I begin? There's 2 zeros on the end, so I know if I multiply some number by 100, I can get 2 zeros on the end of it. And if I multiply 88 by 100, I will get 8800. So that's where I begin. Instead of going through this list here, I just start with two factors that I already know exist for this number. And then I break those down. These are composite numbers. Neither one is prime, so I know I have to keep going. What times what is 88? Well, 8 times 11. And now I want to keep going here. I'm going to break down 100 into 10 times 10. Okay, so I have all this. Now I already have one of the prime numbers, but the others are not prime, so I need to continue to break those down into factors. I know, because I've done this many times, that 8 is 2 times 2 times 2. That's basically the prime factorization of the number 8. Because 2 times 2 is 4, times 2 is 8. And if I were to break, and that breaks that down so that now we have only prime factors of 8. And we've got this. Now we can break down our 10, both of them. 2 times 5. And 2 times 5. And all of these are multiplied continuously. Basically, I would just pull the 11 down in here and that multiply on either side of that. Just kind of pull that down. Even if you didn't pull that down, if you circle all your prime factors as you go, you will have gotten 2 times 2 times 2 times 11 times 2 times 5 times 2 times 5. Well, that is a lot of 2's. So let's put them all in, now let's keep it red. Okay, 2 times 2 times 2. I'm putting these 3 2's. And now I'm going to jump over and pull these 2's in so that we have all the 2's together. Times 2 times 2. And now I'm going to go 11 times 11. And what's left are these 2 5's over here. Times 5 times 5. Which then is 1, 2, 3, 4, 5. This is 5 2's. So that's 2 to the 5th power times 11 times 5 to the 2nd power. Okay, so that's the prime factorization 8800. Well, let's look at the other methods in case that didn't, if this is too confusing for you. There's other methods. What's this little thing? Cake method. That's where we start with our division cake in a sense. We'll start here at the bottom, 8800. One thing that's nice about this number, 8800, it's even, and that means our first prime number. Why do I have a 1 there? Curious. Our first prime number is 2. This is a list of prime numbers just up to 19. You don't have to list all the way to 100. Just list some of them, because you can usually work through these prime factorizations just with the first 5 alone. Alright, so into 8800, does 2, the first prime number, go into 8800? Yes, it's an even number. And basically you're looking at what would half of 88 be? 44, and you just put the zeros up there. So you have half of 800 then is 4400. Okay, and then you start building your cake. So you look again, you ask the same question again. This dividend 2, of course, goes into 4400. We're going to have a lot of 2's, as we know already. So 2 into 4400 then is 2200. And this is what I just did. I did 2 into 4400, that's 2200. Now 2 into 2200 is 1100. I'm just basically cutting 88 in half. I cut 44 in half to 22. Half of 22 is 11. Okay, now we have half of 1100. We have to think a little bit. Half of 110 is 55. So it's 550. And the way I looked at that was, I looked at the number 100, half of 100 is 50, half of 10 is 5, so 55, and then just add a 0. And now we go 2 into 550. Well, half of 500 is 250, half of 250, half of 50 is 25, so it's 275. Half of 550 is 275. So now 2 will not go into 275 because it's not even. Will 3 go into 275? Well, let's do the divisibility rule. 2 plus 7 is 9, plus 5 is 14. If you add those digits up and you get 14, 14 is not divisible by 3. So 3 does not go into 275. So we have to go up another, oh, I'm missing another prime number, I'm sorry. 5 should be on my list here. 5 is another prime number, and that's the one we're going to use to go into 275. Why do I have this list here? This is a list of prime numbers in order, starting from the smallest. And you could go on to infinity. But we've listed a few of them because you have to go in order when you divide on this cake. Always take the first prime number that this dividend can be divided up into. So 5 into 275. Well, I'm not sure what that is off the top of my head. So let's look at that. 5 times 5 is 25. 25 minus 27 minus 25 is 2. Bring down 5. Okay, so that's 55. That's interesting. So 55. Now we can do it again. 2 does not go into 55. 5 plus 5 is 10, so 3 does not go into 55. But 5 does. And that will give you 11. Now we finally have a prime number on our list. 11 goes into 11. And that's a 1 on top. 1 times 11 is 11. And that gives us the same prime factorization as we got over here. So 2 times 2 times 2 times 2 times 2 times 5 times 5 times 11. This method here and the tree method put it in order. This method does not put it in order. So circle your prime numbers so you don't lose track of which factors you're trying to write out. Delete the tree method. The tree method is going to look a lot like this method, but the tree method will be done in order instead of in any old order. So if you start with 8800 at the top, 8800 So I think of what times 2 is 8800. Instead of saying, does 2 go into 8800? Although it's very similar. So 2 times 4400. Trees work down, and you're kind of thinking more about multiplication than you are division. You know, I've got a prime number, but this one is still composite. But we know already, we know the answer to this whole problem, in fact. 2 times 2200 is going to be 4400. Make sure you circle your prime factors as you get them. 2200 needs to be broken down. So that is 2 times 1100. Now let's circle our prime factor. And 1100 can be broken down still to 2 times 550. Alright, and let's circle our prime factor that we got. 550 still can be, 2 times something still is 550. 2 times 275. And circle your prime factor. Now 275. 2 times something is 275? No. 3 times something is 275? No. 5 times something. But 5 times what? We already figured that out over here. 5 times 55. And then we would break, 5 is a prime number. So then we keep, 55 is not, so we have to break 55 down into 5 times 11. So now we finally have all prime numbers. Just like this one, we all came out with the same answers. So the prime factorization of 8800 is 2 to the 1, 2, 3, 4, 5. 2 to the 5th power times 5 squared times 11. And each one of those ways of doing it came up with the same thing. Here's 5 2's, 1, 2, 3, 4, 5. 2 5's and an 11. 1, 2, 3, 4, 5 2's, 2 5's and an 11. Okay.